Hey guys, so today I'm going to be showing you my newest robot I created with the EV3 Mindstorm set, and this one is actually a Metronome robot. And it is by far the most coding advanced project I've ever done. The physical design of itself is basic as they get. You got the arm with the medium motor inside, waving it back and forth. You've got a button and the IR sensor for when I was testing it out. The cords just kind of tangle in the back, plug in where they go, and it's really, really basic. But the programming is what makes this thing so impressive, and I'll show you that. I'll show you what it does first, and then I'll go through the coding simply and kind of go into it a little more advanced for those of you who can actually understand what I'm doing. Here's full speed that it can do, and I highly doubt as a metronome anyone would ever need to use that, but it's there. And then I just put in some average BPMs, so I've got the 100, if they're in here, maybe they're not. Huh, I don't know where they went. Oh, that's because I'm in. Okay, yeah, I'm in the wrong. Okay, so I go down here. I've got 100 BPM, going about that fast, up to 500 BPM, which is near full speed. Anyway, and then, yeah, I programmed some songs. I have click up speed, where what it'll do, every time you click the button, it'll start speeding up, so as soon as it hits, it'll speed up. And then I hit it again, and it'll speed up some more. So, you know, eventually it gets to max speed, and it won't do anything anymore. And then next I have a speed up program where it starts slow and then goes up, and then I have one reversed at that called slow down. We'll start with that one. Starts fast, and every time it hits the wall, it slows down by 1 power level, so eventually it gets to 0 and just kind of shuts off. Or maybe it'll stop at 1 or keep going to 1, and I'm actually not sure. But yeah, you can see it slows down a lot. And then, now this is the reason this is the most technologically advanced one I've done. And what I did is, using this button, you can click a beat in and out, and then it'll go with that beat. This was unbelievably hard to figure out, and I'll explain why in a second. But, so we activate it, and it'll wait for us, so let's just come up with some kind of rhythm. Duh, 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 duh. As you can see, it fairly accurately follows along. We could do something faster, so let's restart the program. Set it to the left. Da 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 da. See? With really slow and really high settings, it can get off a little bit, but you know, just you'll find the average of whatever 8 beats you put in. So if you start slow, go fast, you'll find somewhere between the two, like I just did. But yeah, and that program took so long to figure out, but I did, and it took probably around 2 or 3 weeks just to figure it out and put it all together. I actually went into some graphs, and I'll show you how I did it all when we get onto the computer. So I'll see you in a minute. Okay, so here we are in the coding. I'm going to start out with the really basic ones that took probably 10 seconds to throw together. Then we'll look into the determine speed program, which is super complicated, and that's just the first part. So here we have the full speed. It's really simple. One thing I do want to know is that here, the 0.22 and the negative 0.22, that is the distance between the left and the right hits that I just figured out through trial and error, and I use that in every single one. So here, you know, the power level changes, but the 0.22 and the negative 0.22 stay the same. And that stays the same with all these BPMs. And skipping through, I play a song called Perseus, which is super awesome. It's by an artist, Soon He Newbold. Look it up, it's great. Great song. Anyway, I was just kind of going through that, and the first part is in 6/8 time, so I was 1, 2, 3, 4, 5, 6, and I discovered there's 180 beats until it changes time signatures, but I never really finished the program, because by the time I threw together the program, I was actually already performing the song in concert, and we didn't need it anymore. But I still thought it was interesting. Then here's the click up speed program. It's pretty basic. This top part, as you can see with the motors here, is what's actually running. This is the thinking part, and basically what it's saying is that every time the button is pressed in and then out, which is state 2, then you're going to take the previous variable for ClickUp, add 1, and then register it as the new one. and then just up here it just says, okay, whatever this power level is, whatever this variable is, just use that power level. Still pretty basic. And speed up and speed down are similar, just with reversed numbers, of course. You have the up speed, that's what the variable I named it. You just use that power level here, and then you say, okay, add 1 to it, then do it again, add 1 to it, etc., etc. So those are the simple ones. Now let's get on to the big one. Now, the first thing I had to do for this was I had to figure out the average time between each click. And to do that, I used this timer block, all right? Now, I waited till you pushed it in, and then when you first release it, that's when it starts counting here. And so what happens is when you first release it, it'll start timing and say, figure out how long between each click, and it'll take that time and see these yellow strings, they go into a different thing that we'll discuss later. But it registers the time between each ones and then resets the clock. And it does that 8 times, so we get 8 yellow strings down there going all the way to these variables I created, which was T1 through T8. And that's where they're plugging into. Then, to figure out the average, of course, you add them all up and divide it by 8. So I took them all up and I threw them into this math, which calculates the total, then takes that total, divides it by 8, and we have our average time between each beat. Now this is where it got really hard, because that is just some simple math compared to what I did. So as I put these comments so I wouldn't forget what I was doing, because it was insane. So I just figured out the average time, so I have to convert that average time between each second into a BPM. So that's where I started using graphs. Here I have 1 as 1 beat, or 1 second between each click, and that's 60 BPM, because 60 beats per minute is 1 every second. Now, if you do half a beat per, 2 beats per click, aka, sorry, I don't know what I'm saying. If you do 2 beats per click here, it's going to be 30 BPM half. If you do half a beat every second, or no, wait, what? I don't know what I'm saying. But yeah, you see, this is pretty basic stuff. So I just figured out the equation for that, y equals 60 over x, which goes through all of them perfectly. So I went back into here and I said, okay, you take the average time, 60 divided by that, and now you have a BPM, which is that variable. And this was the hardest part, because now we have to figure out how to convert this universal BPM into what is only used in here, the power levels. So I said, okay, how do I figure this out? So that's where the second graph came in. And right now it's pretty simple because I have most of the things hidden, but I'm going to explain it. So these red dots here, those are the power level and BPM. I went through every single one and created this table. Of course, if you have a power level of 0, nothing's happening, so your power level or your BPM is 0. If you up the power to 1, it becomes 9 BPM. And I figured that all the way through 100 BPM or 100 power level, which ended up to be around 546 BPM. And that's what these red dots are. So then I said, okay, and I did some research on residuals and how to find line of best fits and everything. I found this line, which is the equation for the line of best fit, and that is approximately a perfect line. If these were all in a straight line, then it would hit all the dots, but of course they're not. So then I did a little more research and found that if you take the residuals of that, which are this, and of course the residuals are how far off from the line it is. So you can see around here, look how far the distance between the line and those dots. So then if you go down to the bottom, you can see between 0 and there's a huge difference. But like right here, where the line is hitting the dots, that's where it goes to 0. And we want these dots, the residuals, to be as close to 0 as possible. So I did some more research and I found that there's essentially a curved line of best fit, which is this purple thing I just showed up. And as you can see, I'm going to show you the residuals for that, which are a lot closer to 0. I mean, yeah, they're a little bit off on the ends, but it is a lot closer, and those make it so much more useful. So then I said, okay, how do I utilize this line, this purple line here, to make the power level? So I said, okay, so I recreated it, but instead of y equals as x equals, which was super hard and took a ton of time. But I did that, and I have the left side and the right side. But as you can see, when I'm flickering on and off the graph up here, this little curved one, it actually goes down near the end. And that doesn't work for us because that means that if you were to put the power level at 100, it would be less than, say, 85. And that makes no sense. So what I did is I took that part out, and I created this line, which I'm flickering on and off up there now, which is straight. This is a longer version of it, but I scrapped that because if you zoom in, they have to be at the same Y level, not the same X level.
So I took that, so I have this little line and this big line. So it goes up, and then at this point it stops, and it says, okay, anything above this is going to just follow this straight line. And I found those two equations, which was this really big one and this really small one. The small one is easy because it's a straight line, and the big one is not easy because it's a curved line. So I took those equations. Oh, that's my recording software. Have fun with that. So then we go and we say, okay, where does this line stop at? And we look at the y and we say, okay, if the y is, and we look here, the number is 53.911, I think. What is it? I don't remember. Anyway, if it's 534 point this or above, then it's going to be this really high point on the graph, which is going to be the straight line, and you're going to use the easy equation where you just subtract 446 from it, and that's your power level. But if it's lower than that in this big curved part, then what we're going to do is we're going to throw it through the big equation. And to do that, we have to do this. So we start with y, and in the parentheses, we add this negative, which y minus that. So we say, okay, y, aka our BPM, minus that number equals our power level. Then we take that number, we go back to the equation, we multiply it by this number here. Then, after that, we square root it, then divide it by this negative number, then we add that. Finally, after we do all those steps up here, which is what all the red you're seeing here, that's the math going through the equation. Then we have our final power level, and then of course after that, we just infinitely repeat that power level here and here. And that's how I did it. It took a ton of work, a ton of time. As I mentioned before, it's probably 2 or 3 weeks worth of time. Honestly, I did not think I'd be able to do it. When I was building it, I added the button just for kicks and giggles and said, hey, maybe I'll be able to figure out how to do that. And I did, and I was so impressed. So I hope you guys are inspired to make your own sorts of creations. And I hope you all can learn how to code even better things than this. If you do, comment them your own videos below. I would love to watch them, get some inspiration for my own ideas. I think I have an idea of what I'm going to do next, which is probably going to be a customized bop it. So there's going to be some work on that. Hopefully I'll get that video out soon. Anyway, thanks for watching. Like, subscribe, and comment for more. And I'll see you guys next time.